The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
I want to talk a little bit today about concrete housing and sustainability. And certainly, we just heard about climate change and the impacts climate change have. But they really relate back to sustainability very, very well. When we think about sustainability, we think about the environment, how we must build, in a better way. We think about equity. It's got to be economical. And lastly, we think about our social perspectives, which is about safety as well. When we have natural disasters, there's a lot of impacts. Of course, it's financial. Of course, there may be loss of lives. But we have other things, too, that are implications that are not measurable. Loss of social capital. You've gone to church, to the same church, for 35 years. It's gone. You've lost some social capital. You've lost the elementary school where you grew up in. We can lose identity, culture, historical, and really parts of our community. And the only ways to avoid that is to really be prepared for it. We've talked a little bit about resilience, but what is resilience to you? Resilience to me is really two things. It's resilience in your community, and it's resilience in your home and what you do day in and day out. When we look at resilience, we've just heard about high-performance codes, how our codes need to change. It's to a minimum life safety. But we really haven't talked about materials. What materials should we be using to build our homes? We saw the cartoon about the straw house. We all grew up about the 3 little pigs. How did the wolf blow the house down? How did it stand? Well, when we talk about resiliency, it's a lot about the same thing. How are you going to withstand the next natural disaster? We talk about what is good about resilience. When do you know you've reached resilience or a sustainable home? Once you have the disaster, how long is it going to take you to come back? How long, more so, is it going to take your community to return? If yours is the only house standing on the block, and you used to be in a huge subdivision, I would not call that extremely resilient community housing. You're the only guy left there. So the house we see just standing in the background, what grocery store are they going to go to? What church are they going to go to? What hospital are they going to go to? They have to go hand in hand. Sustainable construction has a lot to do with that. And when we say the best way is when we can get back to service immediately. Hospitals are usually built to a very high standard and a high performance to be operable 24/7. But if the doctor doesn't have a house that he can live in so that he can come to the hospital, again, it's impacting our communities. So if we don't return immediately, we don't really have maximum resilience. So we'll talk a little bit more. I said there's community resilience and what I call functional resilience. Community resilience is when we take the whole package. If that bridge went out tomorrow and we can't get across to the grocery store, it's not a very resilient bridge. And we have to really beef up how we view our communities. But we also must think about the functional structure and the functional piece, and that is your house. When I look at infrastructure, and I'm going to use infrastructure today just talking about houses, the 3 things that we need to be aware of is how robust it is built, the resourcefulness and the recovery that will occur once a natural disaster occurs. We need to build this in a way that is secure, durable, and resilient. And I'm going to give you some examples. I'm going to try to give you some practical examples today of what is kind of resilient and sustainable and the things and tools that you can take away, but more so I want it to be thought-provoking for you and kind of give you some tools to think about. Again, these were just 3 lots down from one another after Hurricane Sandy. I don't think he'll be going through the front door anytime soon. Here, they're going to come back. The neighborhood is probably going to be stripped down, but they can still go back home. I also look at sustainability. When we think about social capital, the things that we think about are safety. It doesn't matter about how well it's built to a LEED standard, but if you can't go back to it, it's really not a sustainable building. The most sustainable buildings you have are the ones that you do not rebuild over and over and over again. So again, I'm going to look at things like durability, resilience, and again, these are to disaster resistance. Where are you going to go during and after your storm? Well, we know what happened here. It wasn't pretty. You know, George going home with mom and dad did not fare well. You just can't live in a hotel because now you're in a bubble, and it's going to get really expensive. I've seen this many times. I'm going to live out of my car now because I got nowhere else to go. I've seen them live out of their boats, their mobile homes. Their houses are gone. But what happened to your capital, your investment? And it is your investment when you look at a home. So again, we come back to society, your safety. We look at the environment, what's standing if it all has to go to landfill. And thirdly, you know, again, monetarily, what's your investment? You can utilize some of the strategies that are out here. I happen to like the Insurance Institute for Business and Home Safety. This is the Fortified. Again, you can get a certificate. The LEED rating system is wonderful. You have to be worried about energy efficiency to be sustainable. But I'm going to take you a step further. Are you sustainable off the grid? And there's reasons I'm going to ask that when we look at how it relates back to climate change and resilience. If we look at storm proofing, here's a leading edge of storms. This isn't even a tornado. This is straight line winds coming in after a heat-related event, derecho. High winds could bring in some hail, could potentially look more like a tornado or a hurricane. These can be winds from 57 miles per hour up to, in some cases, 150. It might be a really long duration. I really don't want to be in that path if I do not build to a particular standard, which is a higher performing standard. This comes out of actually the IBHS guide. We're going to add a little bit of strapping here, and this is to our 2x4s. Now, economically, we're talking about custom-built homes. But if you move into a home, some of these connections are all of $1.57. I don't think it's going to hit your pocketbook too awfully hard, but it could be the difference from you coming back to your house and being able to live in it. I looked at the internet last night because I'm like, okay, am I really off here when I say how affordable is this? The highest one was $50, but it was a very complex system. The cheapest ones were 99 cents. 99 cents. So if you think about your family and how much your family's worth to you, and you have to install maybe, let's say 120 of them because you've got a pretty large area. That's 120 bucks. Last time I checked, your insurance premium is more than $120. Right? It's safety. Let's think about storm shelters. Again, concrete is excellent here, but we don't have to just think about plain Jane concrete. We can use masonry, we can use ICF, and you know, we have some designers who actually design these in their room. Now this is just a floor plan I took, and they've got floor plans all over the place. Here's my safe room right here. What I find interesting about this safe room is, you know, they can make this look pretty glamorous actually. I can have a full-length closet, and it's made out of masonry, and I can still hang my clothes in it, and it's my safe room. And I can make it above ground, if just out here. I can make it below ground, or I can put it in the middle of my house. But there are new concrete ways and technologies and finishes that can be used if you're going exteriorly. I'm not going to take away glory from a presentation later today. They're going to tell you about how to build it. But these can look pretty darn sexy. They can look like your barn. They could look like your child's playhouse. There's a lot of ways that we can use concrete very, very efficiently. Now, the other part of this is you see little air stacks. One of the most interesting safe homes I've ever seen was actually built down in Florida for the president, and it's the bomb shelter. It's on Peanut Island. It's actually larger, but it's all made out of concrete. You walk in and there's the presidential seal. Probably one of the most interesting bomb shelters I've seen. But the case in point is it has a concrete tunnel going in, underground, built with concrete, with ventilation. And you know what? I'm sure the president paid a lot more, President Kennedy paid a lot more. These are on average anywhere between $3,500 and $5,800, or if you make them bigger, they're more expensive. The more you do to them, the more expensive. But again, I'm going to ask you, using concrete to be sustainable and resilient, and when I say sustainable, these could be made with supplemental cementitious materials. They could be made with straight Portland cement concrete. There's many things that we can do here. Flooding. This was the eastern U.S. in 2007. Look at the erosion here. It's awful. Now, I'm not going to steal Ed's thunder, and of course, you've just seen this picture. But FEMA has guidelines for coastal construction. We often see masonry or concrete, reinforced foundation walls, concrete piers. We call them concrete piles in many cases. But again, this was built to a FEMA standard. Now, this does not mean that you cannot make this even more grandioso. And you can see some of these designs on the internet. You can see them implement additional sustainable type attributes. You can add solar panels. Now, I ask you this because where's his power coming from right now? He's got no power coming in. It's going to be hot. How is he going to live off the grid? And this is where we must start looking at sustainable construction. How energy efficient is it? Where can we get our water from? What else can we do if we have to survive in that particular structure? Here's another example of snow load. And you're going to see where I'm going with this in a second. How many people lost power? And if you live in the north, you know what I'm talking about in Buffalo, Boston, Ohio, Pennsylvania. Somebody lost power. My question here is, if you do not design for this correctly, it's going to fall down. You can use precast and other post-tension systems, but more importantly, when we talk about power outages, how are you going to survive the power outage? There's a very interesting video online that talks about, I'm on a back road, way back nowhere, I'm in my vacation home, and I've gone skiing in the mountains, and the power goes out. How do I stay warm? Are you going to be able to stay warm? Well, with sustainable construction, we think about those things. You have to think about thermal capacity, energy loss. How sustainable is your building? And so we might say, what can I use in materials? Do I want to use concrete or do I want to use fiberboard or plywood? If I use concrete, the temperature rise from application. So this is looking in a heat extreme. But I'm only going to raise 2 degrees per hour, and this is at about 90 degrees C. But think of it the other way. If I have to lose temperature. An example is, in Chicago, a colleague of mine lost power. She lives in a home that is actually an apartment building that is brick, and she said she lost power for 5 days. The temperatures outside were 20 to 30 degrees Fahrenheit. She said that even though she lost power, she started at about 75 degrees internal temperature. At the end of the week, she was still at 55 degrees, 50 degrees. She could survive with a coat on. But that's because of the kind of construction she thought about. And knowing that thermal mass makes a difference. And thermal mass is part of the reasons we look at energy. We can design for thermal mass examples. Here's a case where we're building our home, and we might want to look at solar gain. And this is a passive design in which during the winter, there's not going to be a tree here, and the sunlight's going to come in, and you basically have some thermal mass here, so your brick wall. You can bring in the air, and it can be circulated, and you'll continue to absorb and store heat even if your power goes out. Here's the example. This is just a little rendering. Basic solar design. Again, this is summertime. We've got the tree. We've got it opening the window. We've got some skylights coming in. This looks nothing more than I've got a sunroom off the back of my house. The difference is that I've got skylights, I've got a concrete slab, which is providing my thermal mass in this occasion. You notice I still have windows to look out. It's not ugly, it's just not all concrete brick walls. But again, this is allowing some passive solar design. So when we design for sustainable construction and also now for resilient events, these are some of the designs we might employ. We talk about earthquake resistance, and certainly there are guides out there by FEMA documentation, but the key here is it's above code. And we can do sustainable construction above code. A lot of people say, well, I'm using so many recycled materials it can't possibly meet code. When we use fly ash, silica fume, slag cement in our concrete mixtures, we typically are at compressive strengths that are higher than ordinary Portland cement mixtures. We also must think about how well we're using our aggregates. I've never seen where I can not use a slag aggregate or a recycled concrete aggregate. You might lose a little strength, but you're still going to be able to produce a very good quality concrete. This is just some earthquake resistance. This is an ICF type home. This is just a rendering I took off the internet. But we can see the connections and how the connections are well built. Again, as was said, when you have a catastrophic event, you typically have several things happening at the same time. It's not just the earthquake, it's the fire in the earthquake. It's not just the hurricane, it's the hurricane and the water and the flooding that all occurs. So really a lot of the design that you see out there is energy efficiency with connections, with waterproofing, so that you can survive these events. The next one is fire resistance. I've been watching the news while I'm here in Kansas City. I have seen 3 fires in 3 days. 3 fires. What concerns me about this, and I'm going to relate a personal story to you. When I was in college, I lived in one of the apartments, you know, that college students live in. I didn't think anything of it. It was actually on ground. This is not a picture of it. This is wood construction. This is in New Jersey, occurred just a couple of weeks ago. It had fire sprinklers in it. The fire sprinklers were working. Do you think anybody's returning to that structure? No, everything's lost. In college, again, I lived on my concrete slab. It actually had firewall separation between the apartments. They were cinder block. I had my neighbor decide at 12:30 he got home after being outside, and you know, of course, what young men will do, they're going to go to the bar, they're going to have some fun, but he got hungry, he got the munchies. I'm going to make French fries. Puts the grease on the stove and falls asleep. I hear my fire alarms go off. I step out, I have ants crawling up and down my legs, and I'm thinking, this is awful. The fire department is there. His unit is gutted. My bedroom is on the other side of his wall. The only thing that protected me was having a masonry wall that separated me from him. So if you have kids that are in college, you need to go see where they live. I've had this discussion with a neighbor. His daughter lived in the widow's peak. There was one way of egress. Part of sustainability is safety, and there's got to be 2. We immediately went out and bought her a ladder to get out of that widow's peak. I looked in the basement. 7 girls living in this house, mind you, and of course, they got to live everywhere. I saw mold up to here in a wall. They didn't do proper drainage. Again, what kind of house do we live in when it's a sustainable house? We have good environmental air quality inside. There are things that they could have done in this building with proper trenching, proper drainage to make sure that mold was mitigated. Another thing I'm going to relate to you is a story of a friend. They lived very close to me. They lived in a building, a home, beautiful wood shake shingles, beautiful cedar siding, and a lot of mulch and very nicely landscaped. Only one problem. The husband, he liked to smoke, and his wife's like, honey, you're not smoking inside this house. We just got everything repainted. So he went outside on Christmas Day. Family was there, went out, smoked, put it out. Guess where he threw it? In the mulch. They woke up the day after Christmas to their house on fire. So when we build, there's a couple things. Not only do we have to think about the structure, we have to think about the landscaping around the structure. Typically, when we look at sustainable construction and sustainable landscaping, we're looking at native plants. We also look at things that we can use concrete for. Today, there's a lot of entertainment that goes on at home. So you have patios, you have slabs, you have all of these things. Right now, when you think about this, when you design, and when you're thinking about using plant and aquatic life and so forth, you really need to think about 100 feet around your home as your zone, your protection zone. And when we saw some of these forest fires and you look at those houses and you look at how they're landscaped, which some of them are sustainable landscaping, which meets a sustainable sites rating system, they look at these things. You notice I don't have a lot of material here that's going to burn. I have, again, room between the house and between where the brush is. I also have a lot of stone masonry here. Stone walkways, these are all plants that can survive. Some are succulents. You can see stoneways. You can see a lot of different design. The other thing that we often see is that, again, if we have to live after a natural disaster, we can use features such as pervious pavers or pervious concrete along with a cistern system in which we could take that water, capture it as well. It can go through a filter system and we could live off of that water. I lived in a masonry home. We had a cistern and we used the water from our cistern, which was collected off of our rooftop. So again, there's several ways that we can build into a sustainable situation. There's a lot of innovative solutions out there that we may not think about when we think about the construction of our homes. We can think of superstructures. We can use things like semi-precast double wall, hollow core columns. We can think of watertight concrete, renovation. Now, ultra-high performance concrete is way out there, but if we're doing a facade of, say, an apartment or multifamily residential, we might be able to use ultra-high performance concrete in different ways. We need thermal solutions or vertical villages. We also have adaptive housing. So what I challenge you to do is today, when we think about sustainable housing, think about your pavements and your building facades. How energy efficient are they? Think about your envelope design. Is it energy efficient? Can you withstand that snowstorm that's going to leave you without power? Water efficiency. Do you have the ability to collect water and filter it or have water storage? It's now we're seeing cooler communities, so higher energies, lighter colors. And I talk about practicality. But more so, it's about these two items, energy efficiency and water efficiency for sustainable design. And, you know, it's really about buildings, green infrastructure, water, energy, and smart growth. There are some documents out there that I invite you to go look at on the web. The MIT Concrete Sustainability Hub, and Reed's going to be talking a little bit about this, talks about hazard mitigation assessment methodologies. There is a lot of areas where you can receive information about resilient housing. There's Splash, FEMA, CARI, Rescue, IBHS, National Institute of Building Sciences, the mitigation movement. You can also follow the Lead for Homes. There's other rating systems out there other than those. And realize that concrete offers you strategies. And again, this is similar to what Steve had said before. Unequal passive fire resistance. And again, during that storm, your neighbor's 2x4s may be flying, but you don't want them going through your living room wall. You know, so let's build appropriately. So thank you.